let's try to solve another Leetcode problem. 1847, closest room. Let's first try to understand the problem. After that, I'll go through one by one to explain how we can solve this kind of problem. First of all, let's just check the problem. There's a hotel with n rooms, and the rooms are represented by a 2D integer array rooms. So the room's ID, rooms I, is just with the room ID and size. So for example, the first one, the room ID is 2, the size is 2, and the next one, the room ID is 1, the size is 2, and last one, the room ID is 3. And it is also mentioned that the room ID is unique, and the size can be different size, but they can also be equal. Yeah. And for the queries, it is the preferred ID and minimum size, and this is for the queries. Yeah. Now, what are we gonna do? Let's just check the return. And we're gonna return a query. We're gonna return an answer array, and this answer array gonna answer each of the queries. And it's gonna be the length of the k. So where answers j contains the answer to the j's query. So for example, my first query is 3 and 1. So I'm gonna check all the rooms which is bigger than 1. So the first room bigger than 1, I have an ID of 2, so I put the ID inside. The second one is bigger than 1, I put ID 1 inside. And the third one, 2, bigger than 1, I put ID 3 inside. Yeah. And what is my preferred ID? So my preferred ID is 3. This is my preferred. I want to find a number which is closest to this 3. So which one? 2, 1, or 3? Definitely 3 gonna be closest to 3, because absolute of 3 minus 3, it's gonna be 0. Yeah. It seems this problem it can be solved. But how can we find this 3? As you can see, the 2, 1, 3 is just inside a container. And you can understand it, we're gonna put 2, 1, 3 inside a balanced binary search tree. Or in Python, we can put it inside a sorted list. So it means all the numbers gonna be sorted. So this means if we put 1, 2, 3 inside a container, inside a sorted list, basically we're gonna use a binary search to solve the problem. So we're gonna use binary search to find the position, which one gonna be closest. So definitely it's gonna be this position, this is 3, this ID 3 gonna be closest. So we're gonna return this ID. Yeah. But what if we have more? I mean, what if we have more rooms? So currently, for this query, we are checking all the rooms which is more than 1. Yeah. So what about the next room? So the room size is 2. So we're gonna check all the rooms which is more than or equal to 2, right? But inside the container, we are not sure, because inside the container, we are just checking more than 2. So for the more than 1, more than or equal than 1. But for the next one, maybe we're gonna check it. Maybe for the next room, we're gonna check it. But what is inside the container? It is always more than 1, but we are checking more than or equal to 2. It means we cannot directly check the container, check the sorted list like that. We have to do some operations. So what are gonna be the operations? So normally for solving this kind of offline problem, we're gonna call these queries if we are giving a queries of all the queries. So definitely this is gonna be an offline problem. So we call it offline algorithm. Normally there are some ways to solve the offline algorithm. One of the first ways is greedy. So we're gonna sort the array, and we're gonna sort the rooms, sort the queries. Yeah. So the obvious way is to do some manipulations with the queries. Maybe we're gonna just try. Maybe we're gonna just sort the queries in decreasing order according to the room size. So let's just do this one first. So we're gonna sort the queries according to the room size in decreasing order. This is very helpful for us to check. So for example, we're gonna sort the tuples. So the first one, after sorting, it's gonna be 3 and 3, because we're gonna sort it according to this one. This is gonna be the minimum size. And the next one, it's gonna be 5 and 2. And let's just try the last one. It's gonna be 3 and 1. Yeah, because we are just sorted according to the minimum size in decreasing order. This is very helpful for us to check the problem just in one loop. Definitely we're gonna solve it. But the total time complexity gonna be n log n. N is the length of the rooms or the queries. Yeah. Now, if we are sort the queries like this, definitely we're gonna check the maximum room first. So this means inside the container, definitely we're gonna put some IDs like 1, 2, 3. So if this 3 is okay, so for the next room, if it is a 2. So if it is a 2, it means the minimum size is smaller. But definitely this 1, 2 has already met the condition. We just need to add some numbers, maybe 4 and 5. But this 1, 2, 3 already meets the condition because for this 1, 2, 3, the minimum size is more than and equal to 3. Currently, we are going to check the minimum size more than and equal to 2. Definitely, it is okay. So in this way, we can solve the problem by using a binary search, because inside this one, this is a sorted list. We're going to use a binary search to check the positions, which one going to be closest to 2, and we definitely can find this one. Yeah. So if we sort the queries like that, basically, we also need to sort the rooms according to the same structure. So we're going to sort the rooms according to the size. Yeah. So the size is 2, 2, 2. So we're going to keep the same position. So for the rooms, it's going to be 2, 2. The next one going to be 1, 2. And the last one, yeah, let me make it clear. So the last one going to be 3, 2. Yeah. Now we can answer the queries. I'll just use one example. So for the first query, let's just answer the first query. So we're going to put all those inside a container, inside a sorted list. So it's going to be 1, 2, 3, because this is just the room ID. 1, 2, 3, we're going to put it inside because all the size is more than and equal to less than and equal to. Yeah, let me just check. Currently, there's nothing inside. We have to make it clear, because all the room ID should be more than and equal to the minimum size. So currently, minimum size is 3, but our room ID is but our size of the room, all of them are going to be 2. So there's no one meets the condition. Yeah. So in this way, for this query 3 and 3, we're going to return a -1. So this is why here you can see that it is a -1. Yeah, because we are just checking this one 3 and 3. 3 and 3 is at index 1, so the answer at index 1 going to be a -1. Yeah. Now let's check the next query. So we're going to check all the room size which is more than and equal to 2. So we're going to put all the numbers, all the IDs inside the sorted list. It's going to be 1, 2, 3. Now we're going to answer this query. It's going to be preferred. The preferred ID going to be, let's check. So the preferred ID going to be 5. So which number is the closest to 5? Definitely it's going to be this is 3. So my answer going to be 3. So this is going to be the 5, 2. 5, 2 is at index 2, so the answer is going to be 3. Yeah. Now let's just try the last query. It's going to be 3 and 1. While we are checking this 3 and 1, so what's going to be inside? Definitely, we're going to put 1, 2, 3 inside as well, because there's no rooms. Definitely it is 1, 2, and 3. So which number is closest to this 3? Definitely this is 3. Yeah. So we're going to put 3 inside the result. So where is our query? 3, 1 at index 0. It's going to be 3. So this is the final result. As you can see, we didn't go through 2 loops. We just used 1 loop to check. So we're going to enumerate the queries according to our condition. It's going to be in decreasing order according to the minimum size. This is just enumeration. It's going to be n log n time. And then we're going to use a while loop to check the room index from 0. Yeah, from 0, 1 until n-1. So we're going to check all of them. But the time complexity going to be n log n. Yeah, so let's just go back to the code. I think the coding is much more difficult than explanation, because this kind of a problem, definitely it is a hard problem. It's not because it is so hard to understand. It is just because the coding part is so difficult. I mean, it may be easy to make mistakes, because there are a lot of conditions we need to check. Yeah. Now let's try to import the sorted list. So from sorted containers, let's import the sorted list first. Yeah. So I'm going to prepare index array. So this is basically going to be a hash table to hash my index, because definitely this query is going to be sorted. And how can I find the index? I'm going to use an index array and to find my position of my index. So I'm going to use a list with a range length of the queries. So this is going to be my index array. And now let's try to find the positions. So the index should be sorted. So it's going to be according to the k should be equal to lambda, and x is just a random index from 0. Yeah. So it's going to be the queries with my position x, and it's going to be according to the queries according to the second index, according to the size, the minimum size. So here it's going to be 1, but it's going to be in decreasing order. So here going to be a -1. Yeah. So let me just return a random array, empty array, and check what is inside this index. You can understand this is why we're going to use this index as our hash table. Let's check what is inside this index. 1, 2, 0. As you can see, this means this is 1 because 3 is the biggest, and then 2, and this is 2, and this is 0 because number 1 is the smallest. This means our index array is right. Definitely we're going to use this one to find the position of the index. Now let's just prepare a result array. So I'm going to prepare a 0 times length of the queries. Yeah, so this is going to be my final result. I'm going to put it here. Let's just check if there's anything else. Let's just define a sorted list because we're going to use it later. Yeah. And I also need to use index. This I is just for rooms. So I going to be starting from 0. So I'm going to check the rooms one by one. Yeah, but I forgot to sort the rooms. We need also to sort the rooms. So the rooms need also to be sorted. So rooms.sort, I'm going to use a lambda function to sort the rooms. So the rooms is also the same way. It's going to be lambda with x, and x is an item of the room. So it's going to be according to the second index. It's going to be the ID of the room, but it's going to be in decreasing order. So it means minus x1. Yeah. And similarly, let me just print out the rooms to check if everything is okay. Let's just check what is the rooms. Yeah, it's going to be 2, 1, 3 definitely because they are the same. Where is the rooms? It's going to be here 2, 1, 3. It is okay. Let's just check the second example and check the rooms. Where's in my rooms? So this is like 5, 4, 3, 2, 1. This means it is according to my requirement. It should be in decreasing order according to the room size. Yeah. Now we finished all the definitions. Now let's get started for the real part of the algorithm. Yeah. So we're gonna check it from the index. So for J, with the preferred, I'm gonna use a preferred. So what is the preferred? Let me check what is how to spell the preferred. It's double R. Yeah. So for J, preferred and minimum size inside the enumerate. So I'm gonna use sorted queries. I'm gonna sort the queries, and I'm gonna use similarly. I'm gonna use a lambda function. So this is an item inside the queries, and I'm gonna sort it according to the size, and it's gonna be x1. Yeah, but I need to sort it in decreasing order. It's gonna be -1. So the structure is the same as you can see here and here. Yeah, but the only difference is here is this x is just an index inside the index array, and this x is just an item inside the queries. So this is why there's a little bit different. Yeah. Now we're gonna check the rooms one by one. So we're gonna use this index I while I less than the length of the rooms, and we're gonna check the size. So the rooms size is gonna be I with 1. So this is going to be the size. If this size is more than and equal to the minimum size, yeah. So that means I'm going to put all those IDs inside a sorted list. So it's going to be the rooms I with, yeah. So 1 at index 1, it is the size, but the ID is going to be 0. So I'm going to put all the all the IDs, all the rooms IDs inside a sorted list. Yeah, and if it is okay, I'm gonna turn to the next one. So I should plus equal to 1. So if it is not okay, so I've already finished my first query. So this query has already been finished, and I can get the result. Yeah. So for getting the result, we need to use a precision. We're gonna use a bisect left to find the precision. As we have a sorted list, we're gonna use sl dot bisect left to find the precision where it is. Yeah. So the precision gonna be the preferred. Yeah. So this preferred is the preferred ID. Maybe I'm gonna use the preferred ID. Maybe here. Here, let's just use the preferred ID. Maybe this is better to understand. Yeah. So if I can find the precision, definitely I can get the final result. Yeah. But you know, for bisect left, we have to check the boundary case. It's really difficult to solve with the boundary case, and it's easy to make mistakes. Yeah. So in order to avoid such mistakes, I'm gonna put some boundary inside the sorted list. So this is better to avoid checking too many boundary cases for the bisect left. So maybe the array is empty. Maybe we can find nothing inside the array. But what if I just put a negative infinity and positive infinity inside? It's going to be better for us to compare. Maybe we wanted to check this number 1. Is it close to the negative infinity, or it is close to the positive infinity? Definitely there's nothing inside. So in this condition, it means we're going to return a negative infinity. So this is just a boundary case. If we return a negative infinity, it means we didn't find it. We're going to return a -1. Yeah. So if there has already been a number 1 inside our sorted list, it's going to be like this. And then we're going to try to find this 1. And how can we find? And we can use a bisect left to find the precision. So it's going to be here. So we're going to compare 1 and 1. It is 0. 1 minus infinity, and it's going to be infinity. So this is closer. So I can get a result of this one. So this is why I'm gonna prepare a negative infinity and a positive infinity inside the result. Yeah, it is very helpful for us to avoid such mistakes, because it's really difficult to check. Yeah. Now we're gonna let me just prepare a minimum index, maybe, because we need to get this minimum index. Let me just set it to be a random value 0. So I'm going to use if tag. So first of all, so for example, I have a number like 1 and 3 inside, and my preferred value is 2. I want to check this 2. Definitely the precision of 2 are going to be here at index 0, 1, 2. It's going to be here. So I need to use this 2 to compare with this 3 and 1. So how can I compare that? So if the preferred ID minus the sorted list with the precision -1, yeah, this means 2 minus 1. Yeah, if this is less than and equal to, yeah, let me just copy it. Maybe let's just use sorted list with precision. I will not copy that, minus the preferred ID. So if it meets this kind of condition, so the minimum ID is going to be so if we are checking this 2 compared with 1 and 3, so definitely we're going to choose this one, because if they are equal, if there is a tie, 3 minus 2, 2 minus 1, there is a tie, I'm going to definitely choose this one. So it's going to be the SL with precision -1. So else, if it is not, so the minimum ID going to be the precision. Yeah. So let me try to use another example. Maybe this one gonna be 4. I'm gonna check 3. As you can see, 3 is closer to 4. Yeah, this is our second case, because preferred ID 3 minus 1 is more than 4 minus 3. 2 is more than 1. Yeah, definitely we're gonna choose this 4. So this is gonna be the sorted list with this precision. Yeah. What if we have some numbers inside? So for example, we have some numbers inside, and we're gonna check a number 5, and definitely this is gonna be the precision, because we use the bisect left, and this is gonna be the precision. So this means this infinity minus 5 are going to be bigger, but 5 minus 4 are going to be smaller. Definitely I can find the value. It is okay because this is the first case. It is okay. Yeah. But what if there's nothing inside? And for this 5, how can we check? Definitely we're going to return a negative infinity. Because for 5, where is my for bisect left, so where's my index for this 5? If I were to insert it use bisect left, definitely it's going to be index 1. Yeah, so this is going to be my position at here. Yeah, but they are equal because this one minus this one less than or equal to this one minus this one. It is equal. So if they are equal, it means I'm going to choose the smallest index. It's going to be here. It means no matter in which case, if there's nothing inside, definitely I'm going to return a negative infinity. So I'm going to check this one later. Now I would to put everything inside my result. So my result would be index with j. I need to find the position of my index. Currently this one is 0 because this has already been sorted, but I need to find the real position. So that is inside my index array. That is why I do this kind of operations. Maybe you are not familiar at the moment, but if you try to do some template questions, you're gonna get familiar with this kind of a pattern for solving the offline problem. Yeah, if you have to do the sorting, and this is better to do it as a template. Yeah, I mean from those two lines, it's gonna be a template. Now we're gonna put the index inside of our result. So the result with index j gonna be equal to the minimum ID if this minimum ID are not equal to negative infinity. Else it's gonna be a -1. I explained why it's gonna be negative infinity instead of a positive infinity because it never have that kind of condition. Even though I prepared a negative infinity and positive infinity, but for the minimum ID, definitely I only have a negative infinity. So this is the entire code. As you can see, it is not so long, but it's very complicated. We have to analyze a lot of things. Now let me run it to check. But actually, yeah, let me try to check if it works first. Yeah, it's going to be quite slow. Let's analyze the time complexity first, maybe. Yeah, so this is n log n time. Even though you saw here is a while loop, but that is why we prepared to do it like that, because while we are using this while loop, it is not another on time. It is just O1. Because for the whole array, this while takes on time. So for average, for each of the items, this while loop, for each of the queries, and it takes O1 time. Yeah, there's a internet disconnection error. Maybe I need to copy somewhere. Oh, now it's okay. It works. As you can see, it passed. Now let me submit it to check if everything's okay. Yeah, as you can see, it's pretty fast. It's 0.3 seconds and everything's okay. And let's just analyze this type of complexity, time complexity. So let's say if the queries is equal to q. So for the query, it's going to be q log q because we sorted the queue. And we also sorted the rooms. So for sorting the rooms, if the length of the rooms is n, so it is n log n plus q times q log q. So this is going to be the time complexity. And for this while loop, while you are getting familiar with the while loop in these areas, it is similar like a sliding window. We didn't use the actual time. This is just O1. Because while we are checking, if it meets the conditions, so for example, we're going to put all the IDs inside a container for this while check. Yeah. So this means maybe this is 10 to the power of 5, this while check. This means for the next query, we will not put anything inside the while loop. We're going to directly jump from it, and we're going to check others. As you can see, it is O1, right? Yeah. So this is why it is just O1 time from here. I think that's for it. You can try to basically solve this problem according to some intuitions basically we can use a greedy, and the sorting is like a greedy, and this kind of a hash table is like a template. I think that's for it. Thank you for watching. See you next time.